Namaste and welcome to Distance Learning Center of Best Montessori Elementary School. I am Ranjan Dhakal. Let's get with the class today. Today I am here with a topic rational and irrational numbers, terminating and non-terminating decimals. I have taken the chapter from class 6. Okay, let's move on. Now here becoming clear, I have taken in two integers. Integers means positive and negative whole numbers including 0. Now in previous videos we have talked about whole numbers and integers. Now moving on to, now I hope you are clear with the integer, and let's get started. I have taken two integers, 2 and 4. Now I am going to go with the operations with taking two of these integers. Now let's go with the addition first. 2 plus 4 with 6, and 4 plus 2 also 6. That means the result is also an integer. 2 minus 4 is minus 2. 4 minus 2 is 2. That means minus 2 and 2. Here also both are integers. Let's go with multiplication. 2 4s are 8. 4 for 2s is 8. That means 8 is also integer. Let's go for division. 4 divided by 2 is integer. But 2 divided by 4, 1 by 2 is not an integer. 2 upon 4 means 1 by 2. This is not an integer. Here all the other numbers, all the results, in case of addition, subtractions and multiplication, we found that the result is always an integer. But when an integer is divided by another integer, the quotient is not always an integer. Here 4 divided by 2, 2 is integer, but 2 divided by 4, 1 by 2 is not an integer. That means this 1 by 2 is a rational number. That means a number when an integer is divided by another integer, then we get a rational number if the result is not integer. That means 2 is an integer divided by 4 another integer, and 1 by 2, the result is 1 by 2, which is not an integer. That means 1 by 2 is a rational number. Then we can say if a and b are two integers, I have taken a and b instead of 2 and 4. Now the expression of the number in the form of a upon b. That means we may do b upon a also, but commonly we take a upon b. That is called the rational numbers. Now the set of rational numbers, that is denoted by the letter Q, and it has a sets of infinity, minus 2. Here look, minus 2 is an integer, 1 is an integer, sorry, minus 1 is an integer. That means in between minus 2 and minus 1 there is minus 1.5, that is minus 3 by 2. This is a rational number. All the integers are rational number. Minus 2 is also an rational number. Why? Because we can do minus 2 divided by 1. Every numbers in the form of a divided by b are rational numbers when b is not equals to 0. Here when b is not equals to 0, in the number line we can see below with the small letters there are integers 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5 on the left. Now here in between there are some of the numbers. Let's with the red dot it. 1 by 2 here, 9 by 2 here, minus 7 by 2 here. These are rational numbers, and we can represent a rational number in a number line. In the same way we represent integer, in the same way we represent whole number. Actually it's more similar to that of integers. Now let's move on to terminating and non-terminating decimals. I have taken 3 fractions here. 1 by 2 0.5, 3 by 4 0.75, 5 by 8 0.625. That means the decimal is ending, that is terminated. Decimal is terminated. Let's move on to another decimal. 1 by 3, 0.3333 and goes on. 5 by 6, 0.8333 and goes on. 6 by 7, 0.857142, 857142. This is non-terminated, not ending. That means these are rational numbers, fractions, even if the decimals is terminated and if the decimals is non-terminated. We have converted this into a decimals. Now let's move. When a rational number is decimalized, the decimal so often may be terminating here, and may be non-terminating here. If the decimal is non-terminating, a digit or a group of digit in the decimal place repeats. Look here, this is non-terminating, but 3 after 3 is repeating, 3 3 3 3 3 3. Here after 8 there is the repetition of 3 again, and here 857142 is repeating, 857142. That means either a digit or a group of digit that is repeating. These type of decimals are called non-terminating recurring decimals. Non-terminating, never ending. Recurring means either a digit is repeating, reoccurring, or a group of digit is occurring. These are also called rational numbers. But now let's move on to irrational number. Here let's take some examples of some of the numbers that are non-terminating, not ending, but non-recurring. The digits doesn't repeat. Either a digit or a group of digit doesn't repeat. Here let's take an example of root 2. 1.41 here, 42, again 13, again 562. Now the digit is not repeating in the same pattern, or a group of digit is not recurring. That means this cannot be expressed in a fraction. This cannot be expressed in the form of a divided by b. Those numbers which cannot be expressed in the form of a divided by b are called irrational number. Here that means root 2 are irrational number. Thus irrational numbers, when are written as decimals, do not terminate, do not repeat. Some more examples can be root 5, root 6, root 8, root 10. Okay, now let me summarize the chapter. Rational number means the numbers that can be written in the form of a by b, that can be written in the form of fraction. Irrational number cannot be written in the form of fraction. 2 by 1, rational number. Minus 3 by 2, fraction, rational number. 3 by 4, 0.75. The decimal is terminated, ending, it ends at 5, rational. 0.333, not ending, but it is recurring, repeating. 3 is repeating, that means it is a rational number. Root 2, non-terminating, not ending, but the digits are not reoccurring in a fixed pattern. That means this is irrational number. Okay, I hope this is clear, and in the next videos I will be there with some of the examples workout solving the problems on rational and irrational number. Till then, stay tuned to the e-portal of West Montessori Elementary School. Thank you. Bye bye. Have a good time ahead. Stay safe.